We think we know the story of Iberia. We see it in the colossal stones of Roman aqueducts, the intricate tilework of the Alhambra, and the grand plazas of Madrid and Lisbon. It's a history that seems to be written by its conquerors, the Romans, the Visigoths, the Moors, a dramatic tale of empires, glorious battles, and world-changing discoveries. This is the history we read in books, the one told for centuries. But what if that official narrative, the one carved into monuments, misses the most profound story of all? What if the true history of Spain and Portugal isn't just in castles or cathedrals, but locked away in a much more ancient, intimate archive? An archive that exists within the very bones of the people who've walked this land for millennia. For centuries, the earth of Iberia has held its secrets. But now, a revolution in science is letting us listen to what the dead have to say. And their testimony is a game changer. Ancient DNA evidence is revealing shocking migrations, silent invasions, and vast ancestry shifts that don't just add to the historical record, they turn it on its head. The story we thought we knew is just the surface. The real drama, the deepest secrets of Iberian identity, are being unearthed not by archaeologists with trowels, but by geneticists with sequencers. What these ancient bones are telling us changes almost everything. They speak of vanished fathers, a ghost population that disappeared without a trace, and a silent genetic revolution that history completely forgot. This is not the history of kings and conquerors. This is the hidden history of the people themselves, written in the language of our genes. And it's a story far more dramatic and surprising than we ever could have imagined. Imagine this. 4,500 years ago, something happened on the Iberian Peninsula that was so transformative it defies easy explanation. It wasn't a war documented by any historian, nor was it a cataclysm remembered in myth. It was a silent, creeping event that took place over generations, and it resulted in the near-total disappearance of an entire population's paternal ancestry. That's right. Nearly every single man's lineage, the fathers, grandfathers, and ancient patriarchs who had inhabited Iberia for thousands of years, the men who built the first great stone tombs, vanished from the genetic record. They were replaced not in a single bloody battle, but in a demographic takeover so complete and so quiet that it left almost no trace in the archaeological record. Who were these newcomers? Where did they come from? And how did they manage to replace over 90% of the paternal DNA of an entire subcontinent? This is the central mystery that ancient DNA has uncovered, a genetic crime scene 4,500 years old that points to a forgotten invasion that fundamentally reshaped the identity of Iberia forever. This is the story of the vanished fathers. Before we travel back in time to solve this prehistoric mystery, we need to understand the revolutionary tools that made it possible. For most of human history, our view of the past was limited. We had archaeology, which gave us a glimpse into the material world of our ancestors, their pots, tools, and buildings. We had written records, but those only cover the last few thousand years and are almost always biased, written by the elite, the powerful, and the victorious. The stories of ordinary people, of migrations and population changes were often lost to time. But in the 21st century, a new kind of history has become possible. The field of paleogenomics, the study of ancient DNA, aDNA. Think of it as a revolutionary forensic toolkit for the past. Scientists can now extract and sequence the entire genomes of people who lived thousands of years ago, all from tiny fragments of bone or teeth. It's like finding a complete autobiography inside a single skeleton, written in the universal language of DNA. This science lets us do three incredible things. First, we can look at mitochondrial DNA, or mtDNA. This is genetic information passed down exclusively from mother to child. It's a direct, unbroken line to our maternal ancestors, tracing the world's ancient mothers across millennia. Second, we can analyze the Y chromosome, the part of the genome passed down only from father to son. It provides an exclusively male line of descent, a genetic echo of all the fathers who came before. The Y chromosome is a powerful tool for understanding male-driven migrations and population replacements. Finally, and most comprehensively, scientists can sequence the entire autosomal genome. This is the vast bulk of our DNA, inherited from all of our recent ancestors, both male and female. It gives us a high-resolution picture of an individual's ancestry, allowing us to see if someone was a mix of, say, early European farmers and older hunter-gatherer groups. By comparing the DNA of individuals from different time periods and locations, geneticists can build a dynamic map of the human past. They can see when new groups arrived, how they interacted with locals, and whether they mixed or replaced them. Who were the first modern humans in Iberia? Where did the first farmers come from? And most critically for our story, what really happened during the transition from the Copper Age to the Bronze Age? The story of Iberia, as revealed by ancient DNA, is a perfect case study. For decades, archaeologists debated what cultural changes on the peninsula meant. When a new style of pottery appeared, did it mean a new people had arrived, or had the locals just adopted a new idea? DNA acts as the ultimate tiebreaker. It can tell us if the people carrying the new culture were genetically different from those who came before. In Iberia, the answer to that question would be more shocking than anyone predicted. The genetic data has become the ultimate witness, exposing a demographic drama of epic proportions. To understand the scale of the revolution that took place 4,500 years ago, we first have to picture the world that was about to be erased. Who were the people of Iberia before the Great Replacement? The story begins deep in the Ice Age. The earliest modern humans to settle the peninsula were hunter-gatherers. Genetic evidence from individuals who lived as far back as 19,000 years ago shows they were part of a wider European population that weathered the last glacial maximum. These were resilient, nomadic people, hunting large game and leaving breathtaking art in caves like Altamira. Then, around 7,500 years ago, a new wave of people arrived, the first farmers, and they brought a completely new way of life from the Near East, specifically Anatolia, modern-day Turkey. They carried a distinct genetic profile and introduced agriculture, domesticated animals, and permanent settlements. Ancient DNA shows a major genetic shift during this Neolithic period as these Anatolian farmers mixed with the local hunter-gatherers, but their ancestry quickly became dominant. The genetic landscape of Iberia was rewritten for the first time. This new admixed population flourished for the next few thousand years. This was the Copper Age, a time of growing social complexity. These are the people who built the spectacular megalithic structures that still dot the landscapes of Spain and Portugal, massive tombs and stone circles. They developed sophisticated cultures like the Los Millares civilization in southeastern Spain, one of the most important centers of the Copper Age in Europe. Genetically, these Copper Age Iberians were a fusion of the first farmers from Anatolia and the ancient hunter-gatherers they had encountered. Crucially, their Y chromosomes, their paternal lineages, were diverse, representing haplogroups that had been in Europe for millennia. These were the indigenous fathers of Iberia, with lineages that had called the peninsula home for thousands of years. Archaeologists studying this period saw a vibrant, evolving society. They noted the spread of a new cultural trend toward the end of the Copper Age, starting around 4,800 years ago, the bell beaker phenomenon, named for its distinctive bell-shaped pottery. The old historical model, based only on archaeology, interpreted this as a cultural package, a set of ideas and prestige goods that spread from person to person. The theory was that local Iberians adopted these fancy new pots, copper daggers, and archers' wrist guards because they were fashionable. It was seen as cultural diffusion, not migration. After all, there was no widespread evidence of warfare or destruction in archaeological sites to suggest a violent invasion. The bell beaker culture seemed to peacefully integrate into existing societies. This was the accepted narrative for decades, a story of cultural exchange. But it was completely wrong. The DNA extracted from the bones of people buried with these bell beaker pots was about to tell a radically different story. A story not of cultural exchange, but of a demographic cataclysm. The evidence didn't just challenge the old narrative, it blew it to pieces. What happened in Iberia wasn't the adoption of a new culture. It was the arrival of a new people. And their impact, particularly that of the men, was absolute. The crime scene was the entire Iberian Peninsula. The victims were the paternal lineages of the Copper Age men. The evidence was locked in the Y chromosomes of skeletons buried between 4,500 and 4,000 years ago. And when the genetic results came in, they were jaw-dropping. A landmark 2019 study in the journal Science analyzed the genomes of hundreds of ancient Iberians. What they found was a stark and brutal genetic cliff. Before the Bell Beaker period, they found a diversity of paternal lineages common to Neolithic Iberia. But in the individuals from the early Bronze Age, just a few centuries later, those lineages were gone. They had been replaced by a single dominant Y chromosome haplogroup, R1b M269. This lineage was virtually non-existent in Iberia before 2500 BCE. By 2000 BCE, it accounted for the vast majority, over 90% in most places, of all male lineages on the peninsula. The paternal ancestry of the men who built Los Millares had been almost completely erased in just a few hundred years. Overall, about 40% of Iberia's total ancestry was replaced by this incoming population, but the replacement among men was far more extreme. So who were these newcomers? Where did this R1b M269 lineage come from? The genetic trail led thousands of kilometers away to the vast grassy plains of the Pontic-Caspian steppe in what is today Ukraine and southern Russia. This was the homeland of a semi-nomadic people known to archaeologists as the Yamnaya. The Yamnaya were a revolutionary force, having mastered the use of horses and wheeled carts. Their society was mobile, hierarchical, and expansive. Beginning around 5,000 years ago, groups with Yamnaya ancestry began a massive expansion out of their steppe homeland, spreading west into Europe. These migrations are now considered the source of the Indo-European languages spoken across most of Europe today. Genetically, these steppe migrants carried a distinctive ancestral signature, and the men predominantly belonged to the R1b and R1a haplogroups. The men who arrived in Iberia were descendants of these steppe migrants. They weren't pure Yamnaya. Their ancestors had mixed with other European populations as they moved west, forming the groups associated with the Bell Beaker culture. But they carried that unmistakable steppe ancestry, and crucially, the R1b paternal lineage that would so utterly dominate Iberia. This data paints a picture of a massive male-biased migration. Men with steppe ancestry moved into Iberia and, over several centuries, had children with local Iberian women. The daughters of these unions carried a mix of their mother's local DNA and their father's steppe DNA. But the sons carried their father's Y chromosome, the R1b lineage. Generation after generation, this process repeated. The sons of the newcomers inherited their father's R1b lineage, while the sons of the original Iberian men, for some reason, failed to reproduce as successfully. The old paternal lines simply died out. This raises the most disturbing question: how did this happen? The archaeological record doesn't show signs of a genocidal war. The explanation is likely more complex. A scenario described as happening in the bedroom, not on the battlefield. The incoming men may have held a significant social advantage. Perhaps their command of horses, new metal weapons, and different social structure allowed them to achieve a higher status. They may have become a new ruling elite, acquiring more wealth and resources, which in turn allowed them to have more children with local women. In this model, local men weren't necessarily all killed, but they were socially marginalized and outcompeted. Over generations, their lines dwindled as the new R1b lineage flourished. It may also have been that a population already in decline was more vulnerable to being absorbed. Regardless of the exact mechanism, the result was the same: a near-total replacement of the paternal gene pool. The fathers of ancient Iberia had vanished. The arrival of the men from the steppe was a foundational moment, creating the primary genetic bedrock of Iberia that persists today. But the story was far from over. The peninsula's strategic location made it a magnet for subsequent waves of people, each leaving their own genetic layer in the Iberian mosaic. After the Bronze Age came the great empires. The Romans arrived in the 3rd century BCE, and for over 600 years they ruled the peninsula they called Hispania. Roman rule brought roads, cities, law, and the Latin language. It was long assumed the Roman impact was mostly cultural, but ancient DNA is revealing a more nuanced picture. Genetic analysis shows an influx of people not just from the Italian peninsula, but from all over the Mediterranean. The Roman Empire was a great melting pot, and its interconnectedness facilitated movement on a massive scale. Skeletons from Roman-era cemeteries in Iberia have revealed ancestries from the eastern Mediterranean, and even some gene flow from North Africa well before the later Islamic conquest. But the most significant genetic influx after the Bronze Age would come from across the Strait of Gibraltar. In 711 CE, an army of Arabs and North African Berbers, Amazigh, crossed into Iberia, marking the beginning of almost 800 years of Islamic rule in parts of the peninsula known as Al-Andalus. This wasn't just a military conquest, it was a major demographic event. Genetic studies confirm a significant and sustained influx of North African ancestry into the Iberian population during this period. One incredible discovery brings this to life. The genome of an 11th century man buried in an Islamic necropolis revealed him to be a mosaic. His paternal lineage was of clear North African origin, yet his overall DNA showed a mix of both North African and local European-like ancestry. He was living proof of the two cultures merging. The amount of North African ancestry varied across the peninsula, being highest in the south and west. Modern studies show that this ancestry in present-day Iberians ranges from nearly zero in the Basque country to as high as 10% or more in some regions, a direct legacy of Al-Andalus. This period was followed by the Reconquista, the centuries-long campaign by the northern Christian kingdoms to reclaim the peninsula. As Christian rule expanded, the genetic landscape shifted again, with a gradual reduction in the proportion of North African ancestry. However, the story isn't one of simple replacement. In a stunning discovery, genetic analysis of a 14th and 15th century Christian cemetery in Valencia revealed that the people buried there were genetically indistinguishable from the earlier Islamic-era population. They still carried significant North African ancestry. This suggests these individuals were likely Moriscos, descendants of Muslims who had been forcibly converted to Christianity. Genetically, they were the legacy of Al-Andalus, even as they were absorbed into a new religious and political system. The genes tell a story of continuity where history often focuses on rupture. This genetic bridge, however, was about to be severed. Before we get to that final dramatic act, we have to take a detour into the misty mountains of the north. Here, between Spain and France, live a people who represent one of Europe's greatest linguistic and genetic puzzles, the Basque. The Basque people are an anomaly. They speak a language, Euskara, that is a language isolate, unrelated to any other known language on Earth. It's a living relic, a whisper from a pre-Indo-European past. For centuries, this led to the theory that the Basques were a pure, unadmixed remnant of Paleolithic hunter-gatherers, the last true ancient Europeans. Once again, ancient DNA has tested this belief, and the results are a masterclass in historical paradox. The genetic data confirms that Basques are indeed unique. They have the lowest levels of North African and Roman-era Eastern Mediterranean ancestry on the peninsula, indicating they were largely isolated from later demographic shifts. It seemed their mountainous homeland had indeed acted as a fortress. But here's the twist. When scientists looked at the Y chromosomes of Basque men, they found the highest concentration of haplogroup R1b M269 in Europe, the very same paternal lineage brought by the steppe-related migrants 4,500 years ago. Around 90% of Basque men carry this lineage. This finding upended the theory of a Basque Paleolithic remnant. The vanished fathers event happened here too. The paternal lineages of the pre-Bel Beaker Basque ancestors were also almost completely replaced. The fathers of the modern Basque people are mostly descended from the same steppe migrants as other men in Spain and Portugal. So how is this possible? How could they undergo the same paternal replacement yet retain their unique ancient non-Indo-European language? Everywhere else the steppe migrants went in Western Europe, Indo-European languages eventually took over. The answer lies in what happened after that initial Bronze Age migration. Studies show that while Basques received the same initial influx of steppe ancestry, they then became remarkably isolated. From the Iron Age onward, around 3,000 years ago, the Basque population stopped mixing significantly with outside groups. This suggests a fascinating scenario. The incoming steppe-related men who arrived in the Basque region did not impose their language. Instead, their descendants adopted the language of the local women. They mixed with the ancient language that would become Euskara. While the R1b paternal lineage became dominant, the local language and culture survived, carried forward by the maternal lines. For millennia afterward, the Basque people remained in relative isolation, preserving this unique linguistic heritage. The Basque people are a paradox. Their paternal DNA tells a story of replacement by outsiders, while their language tells a story of incredible local continuity. They are the people who remembered a language that the rest of Western Europe forgot. Our journey through Iberia's genetic past now arrives at its final tragic chapter. We return to the 17th century, where the descendants of the Moriscos, the forcibly converted Muslims, still lived, carrying a genetic link to North Africa that had endured for nearly 1,000 years. Though officially Christian, they were viewed with suspicion by the Spanish crown and the Inquisition. This tension culminated in a brutal decision. Between 1609 and 1614, King Philip III of Spain decreed the expulsion of the Moriscos. It was one of the largest acts of ethnic cleansing in early modern European history. An estimated 300,000 people were systematically deported, primarily to North Africa. In the Kingdom of Valencia, where they represented up to a third of the population, the expulsion left villages empty and transformed the region. Historical records tell us this happened. But ancient DNA provides stark, chilling proof of its demographic consequences. A groundbreaking study analyzed skeletons from cemeteries in Valencia from before and after 1609. The results were clear and grim. Individuals from Christian cemeteries before the expulsion still showed significant levels of North African ancestry. But in the remains of people who lived after 1609, that ancestry vanishes. It drops off a cliff. The genetic bridge between Iberia and North Africa, which had stood for a millennium, was abruptly dismantled. The genetic landscape was wiped clean, reflecting the brutal efficiency of the expulsion. The science provides irrefutable evidence of a state-enforced ethnic cleansing that permanently altered the genetic makeup of eastern Spain. But there's one last twist. While the Morisco presence was being erased in Spain, its genetic echoes survived elsewhere, the Americas. Though official policy barred Moriscos from immigrating to the New World, genetic data suggests many individuals carrying North African ancestry had already left Spain before the expulsion. Today, many Latin American populations show traces of North African ancestry, a ghost lineage expelled from its homeland that found a new foothold across the Atlantic. So, what is the story of Iberia now that the bones have spoken? It is a story far grander, older, and more complex than the one written by kings and chroniclers. The official narrative, with its focus on famous empires, has been revealed as just the final layer of a much deeper human history. Genetics has dismantled old myths. The idea of a peaceful cultural spread of the bell beaker phenomenon is shattered, replaced by the reality of a near-total paternal replacement, the mystery of the vanished fathers. The romantic notion of the Basques as a pure Paleolithic remnant has been rewritten into a more fascinating paradox of linguistic survival against a backdrop of genetic turnover. And the history of Al-Andalus and the Reconquista is no longer just a tale of warring religions, but a quantifiable story of demographic ebb and flow. We can now see the arrival of North African populations, their centuries of mixing with locals, and the brutal, genetically verified ethnic cleansing that severed that connection. The history of Spain and Portugal is not a simple lineage, but a breathtaking mosaic assembled over 8,000 years. It begins with Ice Age hunters, is transformed by Anatolian farmers, and is then fundamentally redefined by the silent invasion of steppe-descended men. It is later enriched by genes from across the Roman Mediterranean, profoundly shaped by centuries of contact with North Africa, and then violently pruned by royal decree. This new history, written in DNA, is about the people themselves. It reveals that the great transformations in Iberian history weren't always loud, spectacular events. The most profound revolution of all, the one that replaced the fathers of an entire subcontinent, was a silent one, forgotten by history for 4,000 or 500 years. The past, it turns out, is not truly dead and buried. Its echoes are not just in the ground beneath our feet, but in the double helix of every person of Iberian descent living today. The legacy of the farmers, the steppe horsemen, the Romans, and the Berbers is alive in their DNA. The history of Iberia was not just written by conquerors, it was written in the blood. And now, at last, we are learning how to read.